Oh yeah, back in action. I don't know how the audio sounds because the camera's in the mount. But yeah, I had the issue with the paramotor. Got myself the new coil today. Ran out here like a child. Had to pay $46 on Amazon to get a little kit because the coil did not come with a boot. So I had to get the spark plug, crimper, and all that. But I'll make a quick video on that. I'll edit into this. But yeah, mounted the coil. Got the ground wire going here. Got the AC coming in from the stator here. The green wire is a kill switch that goes for the master power. So right now it's grounded. And when I turn the master off, it'll take the ground off of here, allowing the coil to work. So, with that said, we can energize it and not kill it with the kill switch. And, oh, we do not want it to fire over. I know, safety first. Make a better video if I chop my fucking hand off. Keep smashing my head in the kayak that's up here on the lift. Yeah, anyway. Not that you care about that. Take this part out. Push it into the boot. Hold on 1 second here, kids. Get it so I can reach it. And I know some cameras will pick up spark, some won't. So hopefully I can get this in a place where you can see it. Just lost the fucking spark plug. Dig around through my new net that I put on my cage. Get that there. Get that there. Hopefully the camera will show it. Here's the start button. I'll try to move the camera a little as I go, so you can kind of see it sparking. Hopefully. Yeah, so we got good spark. Very, very, very happy with that. Alright, so the problem was the coil, and if you're bored and have some free time, I'll go into how I diagnose the coil, and we'll go from there. So let's go back inside. Couldn't really see the spark in the other video, so I'll try and do it again. With it laying on the engine, maybe we can get it to ground that way. 3, 2, 1, noise. I saw it. Don't know if the camera really picked it up. So I had to buy this crimping kit on Amazon for the spark plug because it just came with the wire and no boot on the end of it. Had to figure out how to use it. Figure I'll make a quick video, show you. So they sell you this crimper thing, which has a jaw for stripping the wire because you want to expose just the metal core. And it's pretty simple. You just put it on the core, cut it down, roll it. 1, 2, 3. Trim that off if you want. I'm not going to trim it. I'm just going to do it like this. So that will go on there. You have your crimps. These two little lines are considered double crimps. Obviously this is the part that the spark plug gets pushed onto in the boot, and this is the crimp part. So my question was, does it go with this line you're bending back on the bottom, or does it go over here on the top? So this always goes to the back of your plug, so it'll be there. You know, obviously lays into there. That's why they're saying you trim it. So you trim off about that short up to there. And then my next question was, well, when I put it in this crimper and I'm crimping it, try to get it all the way up there, does it go in the crimper face down? Does it go ass up? So on the crimper there's a little, this is for double crimps, this one here, and this is for your single crimps here. So you got your single crimp, your line cutter, splicer, whatever, and then you have your double crimper here. So the oval part, not the open part, but the closed part will go down, and then this part will close it on top. So it goes in with, so put it like that. We'll open the crimper, we'll put it in there like that. Get it, I guess we can get this to where it's relatively straight. We're pushing in. You'll see it. See how it's off? So you actually want to maybe close these a little bit by hand. Just close them up a little bit so they kind of grab in there. Can this man hold anything? So yeah, bottom, try to do this off camera with the angle. Get it a little crimped, held in there, and then like I said, this line on the bottom, in, squeeze, and then it crimps it. Where that little point is on the top here, it's obviously where it's closing up here, and then it's going to crimp the wire there, and then you would, like I said, cut that piece back right there originally, or you can snip it right now right there. But yeah, that's how that goes on. If you ever get a spark plug and you need to crimp it, and then you'll just take your boot, put some dielectric grease, help it slide on, slide it in, and then it can boop, pop into the spark plug. For the one that I have out there, what I did is came with 3 different sets. So it came with the 90-degree ones, and then these are considered 180 degree, I guess straight down. And this other one here. Anyway, shits and giggles. Let's get into the diagnosis on the coil though. Stator, mashed potato. Here's how I diagnosed the difference between the stator having the problem and the CDI. So, stators, they say you test the wires and you should continuity and ground and all that stuff, but you can see on the stator, obviously the main windings are grounded to the base. This isn't about the stator, it's not about AC stators, it's not about DC stators, it's not about grounding or whether they should be connected. It has to do with the CDI. So, the stator puts energy out on these 2 wires, your yellow, and this is a red and white. Forget about colors, but for all intents and purposes, it's putting out alternating current there. And then that alternating current will generally go to a battery. Now, if whatever device you're using doesn't have a battery, then that doesn't really matter because you're not rectifying it. It might just run lights off of AC current. It's not about that, it's not about the stator, it's about CDI. So on the CDI, there's 2 terminals. This is generally your ground terminal. This is the blue wire, or the wire coming from the stator that would attach to the ground terminal, so that when the spark comes out of the secondary coil on your spark plug, it wants to jump to ground, which is bringing it back to the source, the stator, where the energy is coming from. The problem was I wasn't getting spark. I measured the stator. I put 2 wires here, a wire here to ground, put a wire on the main to ground, and I was getting 54 volts. So I knew the stator was working. It was putting out AC, it was putting out 54 volts of AC, but I wasn't getting the spark. So then I went to looking at the CDI. So CDIs, if you're not a multimeter whiz, you're going to have, I'll light up for you, hopefully you can see that, ohms, mega ohms, and kilo ohms. Obviously, mega ohms are thousands, kilo ohms, 10,000s, then you have your regular ohms. Change it up here on this meter to diode. AC power that's coming into the coil should basically come in, and it should be stored until it builds up, and then the CDI dissipates it by sending it out to the spark plug. The problem I have with this coil is, you'll see right now that the positive lead on the meter is put to where the stator would be coming in. This would be the ground. And if I touch it here, you'll see we get a reading of 0.033 volts. Whatever voltage the multimeter is putting out. But you see that there's voltage going through. Voltage should only go one way. It shouldn't go back and forth, because AC power is coming in, going out. Power is coming in, going out. We want the power to stay in here. When I switched these leads, I realized that power was also going that way. 0.03, same thing. That tells me the coil is bad. It's not storing energy in the capacitor. Energy that's coming in is allowed to leave, so there's no way it can build energy to send it out for a spark. As far as measurements from the primary here, or the secondary, so where the AC coil comes in, not the ground side, going out to the spark plug tip, go back to ohms. This is automatic, don't have to worry about it. So it'll tell you M for mega ohms, K for kilo ohms. Touch it to the spark plug tip. That's in kilo ohms. That's where it should be. 4.26 kilo ohms. However, I'm going to edit this in so you can kind of see it. So there's the old coil and the new coil and the measurements that I had. On the primary for the old coil, I only had 25.3 ohms. But when I measure the primary on the new coil, 6.10 mega ohms. That's a significant amount of difference. When I say the primary, I'm talking about both these terminals on here, where if I just see if I get this gears on, I just tried to put these on here and get your reading on the terminals in the primary, 26.6 ohms. But on the new one, I have 6.10 mega ohms. It's a big amount of difference, much, if it's reading that low. So that was one of the signs it was bad. But the number one sign, like I said, is that power was going back and forth both ways. Again, if I measured it from the ground side, you know, the ground wire to ground, which is the black on here, and went to the other side, I was getting, from the ground, I was getting, like I said, 4.49, 4.30. So there was high enough resistance in the wire going to the secondary side for the spark. But on the side that we'll be building, the ohms are just super low. And like I said, with the diode test, you could see that power was going in but not really staying in there. So that's just how I diagnosed that CDI. Okay, so of course I had a SD card error, even though I just fixed the SD card. Just to go over the stator again. So wires in your stator are usually one wire, which is one winding end, another wire, which is the other end of the winding. And the way you check those stators is to put one wire into one of those ends and basically one into the other. And you should have continuity, meaning a connection, but it should be really low. Just like you see here, there's 0.4 ohms. So we know that we have a really strong connection. So you know that those wires are good as far as the power side. And then on the ground right here, which is the main ground, going to the main power coming out, you want to have a high number of resistance, somewhere around 300 I heard, or 299. So we have 291.4. So those two readings essentially tell us that the stator's good. We know that we have a high level of resistance between the primary wire, which is sending power to the coil, and the ground itself. I had read that there shouldn't be any continuity or something in the wires or something in the stator where, like, if this is in the ground and this is on the AC, there shouldn't be any connection, but there is. So maybe that's for a DC stator or something like that. Obviously, if this is the ground wire and this is the ground and the wire itself is soldered to here, obviously there's going to be a connection there. So just throwing that in there. So once the stator was plugged in, like I said, I put the meter on AC power. I tried to kick it over. The battery is turning the starter is spinning the flywheel is spinning around with the magnets on the stator, and I was getting AC voltage between the ground and the power for the stator of like 54 volts. So that told me that the old stator was good. It was getting 54 volts. At first I thought there was a problem because, like I said, I had been measuring it, and they're like, oh, you shouldn't have any of the wires broken, or if they're going to ground, there's something wrong. So once I put, I went to ground here and I measured here, and I heard that, on the AC, the winding side and the ground, and I heard that, I thought there was something wrong with the stator. But the stator's actually fine. So yeah, some stators, they say that these windings shouldn't go to ground, but obviously this design in an AC stator, it's soldered right there to the ground. It's made that way, kids. So that's what led me to going into the coil, and now we have spark, and now I'm happy. So if that helps, it helps. If it don't help, it don't. Filled your day with something to watch. Alright, thanks. Don't click like, don't subscribe, because I have nothing interesting to say most of the time. Or if you're sitting home and you're bored, you can always click like and subscribe and see what kind of odd, interesting shit I'm coming up with. Alright, thanks, bye.